I'm really happy to have Simon Linke back again to do kind of part two of he kicked off with yesterday with a presentation, and so today he's talking on the past, present, and future of freshwater conservation planning in 10 minutes. So.
Yeah, that's right. We put a proposal to Ian for a 45-minute talk, and he gladly accepted us and gave us 10 minutes. I decided to talk bigger. But yeah, I'd really like to acknowledge my very close friend and colleague, Virgilio Hermoso, with whom I've just had this incredible partnership over the last 7, 8 years of coming up with a lot of innovation in freshwater conservation planning. Anyway. What is conservation planning? Just one slide. It's also not only have to talk about past, present, and future, but also really to a very diverse group, from complete freshwater planning nerds to reasonable novices in the field. So, anyway, conservation planning is that across a landscape, given a limited budget, you ask yourself where to allocate conservation restoration efforts. And one of the key principles is the principle of efficiency. So you really want to do this in the most efficient way. Why is that? Because obviously you will always have to prove to someone that you're not wasting anyone's money, and that actually these solutions can exist, a healthy environment as well as minimum impact on stakeholders. Now, one of the key ingredients of every conservation plan since the 1980s, since Jamie Kirkpatrick really launched a few seminal papers, and then Bob Pressey looked back into it. So one of the key principles is the principle of complementarity. Little thought experiment. We have 7 fish species, 5 subcatchments, right? So if we were to use richness scores, which still a lot of people use, so they basically count fish and say, we've got 10 fish here, 15 fish there, 20 fish there. We'll grab the one with the 20 fish that will give us the best bang for the buck. It often doesn't work. So in this case, for example, you would choose planning units A and B if that's the richest ones. If you actually look at the real data, then you can see what the principle of complementarity does for you. If you just look at richness, then these A and B would actually miss those 2 species. So the only way you can actually get taxonomic completeness in your conservation plan is you use D and E, which don't really look all that rich on first glance, but in the end, that they will give you taxonomic completeness. Okay, part 2 of our 2-minute crash course in systematic conservation planning is the last one. So the first one is the principle of complementarity. The second one is the principle of cost effectiveness. And you really have to address that straight away, because otherwise you run into all kinds of troubles. Again, same thing. You've got 2 conservation plans for exactly the same fish. Here, you've got one with 3 planning units. Here, you've got one with 2 planning units. If you don't consider the cost of the protection measures in those planning units, you would actually go with this one, right? No, you would actually go with this one, because it's only 2 planning units. However, they are expensive. This, on the other hand, is the most efficient way to conserve all the species, based on the principle of complementarity and the principle of cost effectiveness. Okie doke. That's what we call systematic planning. Now, as I said before, these methods have been around for a long time. There's applications called Marxan that people have planned for reefs, continental assessments, and also terrestrial continental assessments. And all of these plans are usually done for biodiversity patterns. Now, I think what's really important is actually to put in some process-based information. So, what are aquatic processes that we can plan for? And thanks to Virgilio for letting me steal his awesome slides. So obviously, there needs to be some upstream-downstream connectivity, right? You cannot just use the terrestrial approach, kind of like, put a blob of area in the landscape and things will be good. You have to think about how fish migrate, for example. Or you have to think about how nutrients flow from upstream to downstream. But the good news is that I would consider especially longitudinal connectivity largely resolved. I'm not going to tell you, it will take me at least 20 minutes to tell you all about the stuff that me and Virgilio and Jean Nell, who's hiding up there, Jean Nell and Aaron, like all of us have done stuff with connectivity in the last few years. Also Arte Moilan and Carissa Klein, I wanted to acknowledge these guys, they have really pushed this field to the max. We also now have a fantastic product called HydroSheds, which is basically pre-cooked planning units that have the spatial information, how the planning units relate to each other, already built in. What about other processes? What about disturbance? Obviously, you really have to know exactly where your protected areas should be in the landscape, because otherwise you place it exactly downstream of agricultural or urban impacts, and your fish will not be very happy. Again, I think that's largely resolved. There's a lot of papers, especially Virgilio and I, also Jean. Jean published, and something that we've recently done, for example, is that we looked at fish in the Congo River and looked at transboundary impacts. Again, so condition and connectivity, I think, are largely resolved. Let me move to a few things, and from now on I'm just going to throw some ideas out for later discussion. So, things where work is in progress. Wetlands is an interesting case. So there have actually been a couple of interesting studies planning for wetlands by, for example, Bernardo Lurival in doing some stuff in the Pantanal, or another friend of ours, Angelo Say in New Zealand. But it's problematic because none of them, if you look at these Pantanal examples, none of them really use the spatial context of the wetlands, so the wetland connectivity and the wetting drying cycle. The spatial aspects are really not explicitly addressed, so that's definitely something that all of us planners need to work on badly. How to integrate lakes. We've published so much about river conservation planning between a lot of people in this room, but lakes, it is really difficult. We actually found one single proper systematic planning exercise for lakes out of Patricia Serrano's lab in Michigan. And but these were just small lakes, right? So yes, it was landscape-based prioritization of lakes. But what do you do if you've got a lake like Lake Tanganyika? What's the best measure for a large lake? Again, lots of work to be done. Changing tack, genetic processes. Hardly anyone ever has studied genetic processes in any freshwater system, really. We just got a paper in press in PLOS One where a student of mine looked at, she was trying to plan for stygofauna, but 70% of stygofauna in Australia actually remains undescribed. So what she did is she said, I don't care what we call these things. What we want to maximize in our conservation plan is just the phylogenetic tree. And yeah, again, I think that's kind of like a single study. There needs to be more of that stuff done. And now I might close with two things that I think also need to be discussed. things that are largely unresolved. One of them, and that's really ouch, a real ouch thing, is temporal scheduling. When do you do what? I've had a PhD student, Sam Nicol, who did some temporal scheduling and had these grand plans. In the end, the temporal aspects of conservation scheduling are so complex and computationally intensive that he could only really use 8 water holes, with 3 water levels for his models, and even that ran for 5 hours or so. So it's something that is really hardly ever done, but is really needed for scheduling of, for example, temporal protected areas, for water releases from dams or other temporal aspects of conservation. So I think it's really important. And the last one is really kind of a framework it was largely unresolved until about a year ago, and I think that's kind of one of the holy grails of conservation planning, is to not just look at the landscape and look at species in the landscape, and if you lock up a certain area, then everything will be fine, but really to have an explicit link between, I'm going to spend some conservation dollars here, that is going to give me some spatially explicit management actions. With those, I can remediate all kinds of threats, grazing, fire, repairing, clearing, stuff like that, and then I will have then I will plan for direct benefits to all kinds of biota. When I say it's largely unresolved, unfortunately Lorenz is not here, otherwise I would embarrass him, but one of our colleagues pretty much solved it. We will report on that soon. But it's still, he found one way of solving that, but I think that is really where major work should happen in the next little while. To conclude, since the last World Parks Congress, I think really, and that's again, thanks to people like Ian, Aaron, Dirk Rue, Jean Nell, all the other amazing people, Bahilio, all the other amazing people in this room, really a lot, we've had a quantum leap in aquatic conservation planning. However, some realms, lakes, wetlands for example, have still been largely ignored by all of us. And all in all, I think what should really happen is to have a more process-based view of conservation. Thanks heaps.